Hi everybody! Today we are talking about a nice and quite famous mathematical riddle. It's about a cat who wants to go through two ropes that rope around our planet Earth. Let's start with some information about our planet. The radius of the Earth is more or less 6,371 kilometers, or if you prefer, 3,958 miles. That means that the equator should be more or less 40,030 kilometers, given by 2 times pi times r, the radius of the Earth. Well, not only the equator, but any great circle around the planet. For example, we can take a circle passing through the two poles, north and south. However, our planet is not a perfect sphere, so the length of the equator is actually closer to 40,075 kilometers, which is almost 25,000 miles. But you will see that all this doesn't really matter, because we won't need any of these numbers. Anyway, in order to avoid problems, let's just assume that our planet is actually a perfect sphere. That means that we can assume that any big circle around the Earth has length 2 times pi times r, where r is again the radius of the Earth. Now, let's take a very long rope. How long? We want it as long as the equator. That means 2 times pi times r. No need to compute it again. No need to replace it with the 4,000 something kilometers that we computed before. You will see that soon everything will disappear. But that's not it. Let's take a second rope. This should be long like the previous one, plus 1 meter. So 2 times pi times r plus 1. Remember that 1 meter is more or less 3.3 feet, if you prefer. So the problem is the following. We have our beautiful planet. We rope the first rope around the planet. Then we rope the second rope around the Earth too. It is longer than the first one, but we want to make a perfect circle with center again in the center of the planet. So exactly here, well, more or less exactly. And remember that the difference between the two ropes is just 1 meter, or as we said, 3.3 feet. Then we take a cat, and we wonder if it can pass through the two ropes. Let's compute this. So remember, we have our first circle. The radius is r. And our second circle, whose radius is r prime. The circumference of the first circle, I will call it c, is given by 2 times pi times r. And the circumference of the second circle, which I call c prime, is given by 2 times pi times r prime. But we know that this second circle is exactly equal to c plus 1 meter. Okay, so this is equal to 2 times pi times r. This is the value of c plus 1. Now, what does this mean? It means that we have the following equation. 2 times pi times r plus 1 is equal to 2 times pi times r prime. That means that 2 times pi times r prime minus 2 times pi times r is equal to 1. We go on, and we have 2 times pi, which multiplies now r prime minus r prime minus r, which is equal to 1. This implies that r prime minus r is equal to 1 over 2 pi, which is more or less equal to 0.16 meters, or if you prefer, it's more or less 6.3 inches. And this is giving us the difference between the two radius, between the radius of the big circle and the radius of the small circle. As you can notice, we have never needed the information about the radius of the Earth, because it simply disappears. In conclusion, we just computed the radius r prime of our second rope, and we compared it with the radius r of the Earth. The difference r prime minus r is just 16 centimeters, or as we said, 6.3 inches. Please notice again that we never needed to use the actual value of the radius of the Earth, because it disappeared in the computations. What does this mean? It means that this computation does not depend on the radius of the sphere that we are considering. Don't forget that we have our little cat, and now we can finally reply to our question. Can the cat pass through the space between the two ropes? Of course, yes. Cats can pass even through smaller spaces. Of course, I'm talking about an average cat, not a giant one or a tiger or a lion. But the funniest thing is, again, that our computations did not depend on the radius of the planet. So we can actually obtain the same result if we move to a different planet. Or if, for example, we consider the moon or any other sphere, like a tennis ball, or maybe the sun. Well, no, let's not try this in the sun. I'm afraid our little cat wouldn't be very happy. But that's it for today. So stay tuned, because that's only the beginning of our journey. Please don't forget to like, comment, and subscribe. Thank you very much again. Bye.